him. First of all, black holes are created when a singular mass, collapses into each other, itself due to the amount of due to its gravitational pull. That gravitational pull gets so intense that instead of becoming a supernova, it collapses into itself, creating a black hole in which has such a strong gravitational pull that not even light can escape. Yes, not even light. It warps light and space-time itself. But you see, this black hole can create a quasar. Quasars used to be created in the first, I think it was 200 to 100 to 300 million years in the universe. They were very
200
popular
million
back
years
then.
ago. That's more. That's older than.
He really is a yap god.
Okay,
I'm beginning to.
obviously, but anyways, so quasars are created when black holes they absorb so much matter. The matter then creates quasars. Quasars are basically
Quaver. That sounds like some magic
Chinese.
vegetable.
Oh, quasars!
Quasars! We have quasars in our.
Quasars. You see, quasars are basically a food pellet for the black holes. They can eat as much as they want, which leads me to
So,
think
that's
that
basically
black holes,
chocolate with what-
which goes to black hole suns. Black holes aren't sentient, by the way. I'm just saying eat. But black hole suns are thought to be created when the core of an enormous sun collapses into each other. But that sun is so big that the black hole can't keep up with eating the entirety of the sun. So the black hole is just stuck in the core of the sun. It cannot do anything yet feast and feast on the sun. It's the enormous star. This leads to Isaac Newton's law of gravitation. Two masses attract each other. This is why all the planets surrounding the sun go over it. It basically states that force equals two masses applied a mass applied to another mass by a current, which is gravity, divided by distance squared. This leads to the inverse square law. The inverse square law distance, the amount of distance between two masses. The gravitational pull. The gravitational pull is weakened by the gravitational pull is weakened by the distance, by the distance square, which then leads to have work applied over distance. And you see, although work and energy have the same measurement, joules, they are not the same thing. Work is the amount of energy used up to do something. Energy is the amount of work you're able to do. But you see, there are different types of energies. You guys will already know this.
Yeah.
Kinetic and gravitational potential and stir. I'll skip over this because we already know it. Let's go on to entropy. Entropy. Oh no. You don't know this though. We haven't learnt this. This is year 9 level math. Science. Basically, when a car stops, where does that energy go?
To the sun.
If it doesn't hit a wall.
To the sun, man.
If it doesn't hit a wall, where does that energy go? You see, that kinetic energy, because of the friction on the tire, the kinetic energy, the friction creates heat, and since temperature is the average kinetic energy of atoms, the atoms will expand and go into the air, which basically leads us to thinking that the car's kinetic energy moves onto the airs. Now onto entropy, which goes on top of this subject. Entropy is
10 minutes. This may last 10 minutes. You know.
I won't.
Entropy is the amount of disorder there is in the universe.
I've been driving my soul.
By the way, I've always wanted to say this, but
I'm still losing my mind.
Edward, the sun never went to the moon.
I've always wanted to say. Oh, thank you for reminding me about the moon. The sun never went to the moon, Said. But it is. The moon is
Sun
eventually.
going to the moon would be wild.
Yes,
The sun never went to the moon.
I never said that, Said. But you see, the moon was created when enormous other spherical thing smashed into the earth, heating up the earth to such an extent it was uninhabitable. And the Earth's gravitational pull pulled it back into place, which then leads to gravitational pulls. Planets are able to, or moons are able to, the gravitational pull pulls planet to the sun, but the planet has enough speed to get out of that gravitational pull and prevent it from being destroyed. The same with the moon, which creates tides. The tides are created due to the moon gravitational pull pulling onto the tide. When it pulls onto the tides, you see it's still getting out of the gravitational pull. Every year it moves 3.8 centimeters. Was it 3.8? Yes, 3.8. 3.8 centimeters away from our Earth every singular year. And I'll go back onto entropy next time. Goodbye, guys.
Error in my brain.
Oh,
Bro, this is not a YouTube video.
I think Edward just finished.
Yeah, I know.
Okay.
That's kind of obvious.
Yeah, a little too obvious.
Nigga, I swear.
I'm stopping the recording now. It lasted 6 minutes.